ಇವತ್ತು ನಾವು ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟನ್ನು ಕಲಿಯೋಣ. ಆಸ್ ವಿ ಹ್ಯಾವ್ ಡಿಸ್ಕಸ್ ದಿಸ್ ಟಾಪಿಕ್ ಇನ್ ಬ್ರೀಫ್ ವೆನ್ ವಿ ಆರ್ ಡಿಸ್ಕಸಿಂಗ್ ಅಬೌಟ್ ಸ್ಟ್ಯಾಕ್ಸ್ ಆ್ಯಂಡ್ ಕ್ಯೂಸ್. ಸೊ ಹಿಯರ್ ವಿ ವಿಲ್ ಬಿ ಡಿಸ್ಕಸಿಂಗ್ ಇಟ್ ಇನ್ ಡೆಪ್ತ್. So linked list concept, as we know that memory is nothing but a sequence of bytes. When we are storing memory, it is nothing but a sequence of bytes. Okay, when we use continuous memory allocation, if we are storing in this is if it is continuous, memory is continuous. If for example, if I tell AR5, so depending upon the type of data int A of 5, the memory, the operating system will allocate 5, 10, because 5 into integer occupies 2 bytes. 5 into 2 equals to 10 bytes ಅನ್ನು ಅದು allocate ಮಾಡುತ್ತೆ. So this 10 bytes is allocated in this memory continuous way. That is here continuous 10 bytes, 1 2 3 4 5 6 7 8 9 10. So this much bytes will be allocated for AR. But if we want to, then we will start processing. But if we want to increase this memory size or decrease this memory size, here in fixed allocation or static, it is not possible. So we cannot, and this memory is wastage. If we occupy less space, if we occupy only this much space, this space is wasted. Or if we want more space, we cannot occupy here, because we are in the time running the program. So at runtime I cannot allocate memory using fixed or static allocation. So what will happen, I have to again from running, I have to stop this running of the program mode. I have to come back to the main program. Here whenever I am declaring, where I am declaring this array, I have to increase this. If I want 10, I want to increase here. Then again I have to do compilation, then running of the program. So this, the memory wastage takes place. So to avoid this, we will be using linked list concept. Okay, in linked list what will happen, dynamic memory allocation takes place. So if it is this part, your memory, complete memory, if I am using dynamic memory allocation, I will allocate 4 here. Wherever space is there, computer will allocate here. So this is our first data, second data, and here if I want to occupy third, this is our third data, and 10, this is our fourth data. Now when we use dynamic memory allocation, we can store wherever the free memory is there, we can store the memory, we can allocate. But whenever we are accessing, how we can do that? Because after when we access 4, then where we have to go? Since it is not using continuous memory allocation, the dynamic memory does not use continuous memory allocation. So after 4, where we have to jump? Because after 4 there is 3, but the computer will not understand, or we will not understand. So after 4 ನಾವು 5ನ access ಮಾಡಬೇಕು, correct? After 5 we have to access 3, then we have to access 4. So how the sequence we can follow, what sequence we have to follow? So for this purpose we are using the concept of linked list, where along with this normal data we are storing the address of next data, the address where actually the data we are storing, that memory location's address we are providing. So along with data I am storing one more, that is the link to the next address. So data and link are together stored in this. So this usually we call it as a node. This is one single node. So collection of nodes is called as a linked list. So after linked list, now we will be seeing how actually it is represented. Okay, so this is nothing but about the linked list. That is basically it is used to overcome the memory wastage problem of normal static allocation. Memory, we can utilize the memory efficiently. Okay, but the main problem comes when we are dealing with linked list is accessing. So for this accessing method, we are using the second part of the node, that is the link, which stores address. Okay, so now we understood the background, but now when we have to represent the linked list in the computers, through computers we have to implement linked list. So for this purpose we have to use certain data structures. So now when I am telling here, linked list has two parts. One is data, where actually we are storing normal data, and one is link. So this normal data, we can use any data type. Whatever data type we require, we are using it. Data type, the variable, this one, whatever data we want. But when you are coming to the link part, a link is what? The address. So to use the address, we use a pointer variable star. So star. Now what will happen? This link contains the address of next node. It contains the address of next node. So node kind of data. So node is again like this. So for this purpose, here we have to declare a node kind of data, node data type, where we are creating a linked list. Okay, where we are creating the address, it will store the address. So to declare this kind of data, okay, first we have to use structures, because as we know, structure is to combine two different data structures we can combine. So as usual we are calling this as a node. So we are using struct keyword node. Then as I told you, data type, whichever data type you want, we can use. So now ಇಲ್ಲಿ simple ಆಗಿ ತಗೋತಾ ಇದ್ದೀವಿ integer. So we call it as int data we declare. Then now as I told you, the link part stores the address of next. So next node address ಹೆಂಗಿರುತ್ತೆ, ಮತ್ತೆ ಅದು ನೋಡಿಗೆ ಪಾಯಿಂಟ್ ಮಾಡ್ತಾ ಇದೆ. So again I am declaring struct node. ನಾರ್ಮಲ್ ಡೇಟಾ ಅಲ್ಲ, ಅದು ಲಿಂಕ್ ಲಿಸ್ಟ್, ಲಿಂಕ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೆ, ದಟ್ ಈಸ್ ಅಡ್ರೆಸ್. ಸೊ ಅಡ್ರೆಸ್ ಮಾಡಬೇಕು ಅಂದರೆ ಅಗೇನ್ ಐ ಹ್ಯಾವ್ ಟು ಯೂಸ್ ಪಾಯಿಂಟರ್ ವೇರಿಯೇಬಲ್ ಸ್ಟಾರ್ link. So now we have declared this. So this is how we are going to declare a linked list. So ಇದು ಫಸ್ಟ್ ಒನ್ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟನ್ನು, ಈ ನೋಡನ್ನು ನಾವು ಈ ಏನು ನೋಡಿದೆ, if we want to declare that node, we have to use this in C language. So after this, now we will be seeing what are the different types, ಯಾವ ಥರ ನಾವು ಬೇರೆ ಬೇರೆ ಥರದ್ದು ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಇದೆ, ಅಥವಾ ಲಿಂಕ್ಡ್ ಲಿಸ್ಟ್ ಬೇಸಿಕ್ ಸ್ಟ್ರಕ್ಚರನ್ನು ನಾವಿಲ್ಲಿ ನೋಡೋಣ. So here linked list, for example, we will take an example where linked list, the simple linked list will look like this. Okay. ಸೊ ನಾನಿಲ್ಲಿ 10 ಸ್ಟೋರ್ ಮಾಡಿದೆ, 20, 30. ಫಾರ್ ಥಿಂಕ್ ದ್ಯಾಟ್ ಇದನ್ನು ನಾನು 1000ಇಂದ ಶುರು ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ದೆನ್ ದ ನೆಕ್ಸ್ಟ್ ಅಡ್ರೆಸ್ ಎಲ್ಲಿ ಸ್ಟೋರ್ ಆಗಿದೆ ನನಗೆ ಗೊತ್ತಿಲ್ಲ, ಬಟ್ ಐ ಆಮ್ ಗೆಟಿಂಗ್ ಹಿಯರ್ 1000. 20ದಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಡೇಟಾದು ಅಡ್ರೆಸ್, ನೆಕ್ಸ್ಟ್ ಡೇಟಾ ಸ್ಟೋರ್ ಆಗಿದೆ ಈ ಅಡ್ರೆಸ್ ಮೇಲೆ. ನೆಕ್ಸ್ಟ್ ಈಗ ಇದರಿಂದ ಐ ಕ್ಯಾನ್ ಎಕ್ಸೆಸ್, ಇಲ್ಲಿಂದ ನನಗೆ ನೆಕ್ಸ್ಟ್ ಅಡ್ರೆಸ್ ಸಿಗುತ್ತೆ. So by chance I have stored in 3000. This is 3000. So ಇಲ್ಲಿಂದ ನಾನು ಲಿಂಕಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಇದನ್ನು ಯೂಶ್ವಲಿ ಐ ಕಾಲ್ ಇಟ್ ಆ್ಯಸ್ ಅ ಹೆಡ್ ನೋಡ್. ಎಲ್ಲಿಂದ ನಾನು ನನ್ನ ಲಿಂಕ್ ಲಿಸ್ಟನ್ನು ರೀಡ್ ಮಾಡಲಿಕ್ಕೆ ಶುರು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ದಟ್ ಪಾಯಿಂಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆ್ಯಸ್ ಅ ಹೆಡ್ ನೋಡ್. ದೆನ್ ವಿ ಕಂಟಿನ್ಯೂ Okay, when we reach at the end, end node anna if I want to tell that this is the end of the node, we are using a null pointer to show that this is the end of the linked list. So this is our sample linked list where we are starting from one node, that is a head node. There are two methods. One is this head node, we can use a pointer which will store the address of head node. Okay, or we can directly tell this as a head node. So two different methods are there. Whichever you are comfortable, you can use that particular method. Then comes from this link we can access the address of this node. Then the data part, we can access the data. So this is not accessible, this is only for the reference part, but this is the accessible part, so we will access this. Then again it will come to the link part. ಈಗ ಲಿಂಕ್ ಪಾರ್ಟಲ್ಲಿ whenever there is a null, it indicates that the linked list stops here. So this is the basic example of linked list. So now we will go for the types of linked list. So there are different types of linked list. Okay, the 4 different types of linked list are: one is singly linked list. Linked list I am writing like LL. Then comes doubly linked list. Circular linked list. Then last one is doubly circular linked list. So as you can see, there are 4 types of linked list: singly, doubly, circular and doubly circular linked list. So as the name indicates, single linked list means it is the simple one. Okay, next doubly, there are doubles links, linked list links. Okay, so how circular it is in the circular fashion, so we will see one by one. Okay, so when we are going for the first singly linked list, I show it as singly linked list. Okay, so singly linked list, as the name itself tells, it is having a single link. So it is having a single link. Okay, the basic structure. Okay, so single link, and you can only traverse. When we are traveling, you can only traverse in forward direction. There is forward direction, so there is no possibility of coming back. So normal linked list, what we have shown, what I have explained in the last same thing. Okay, so from one node there is only a single link which will tell the address of next node. So this is the link part. Okay, this is the link part. So there is a single link, so it is called as a singly linked list, single link present. So you can only forward, you cannot come backward. So if you want to access the backward, you cannot do it with the help of singly linked list. So for that purpose, you have to use the next type of linked list. So the single linked list is the simple one. Okay, where there is a single link present, a data and the node. So data in the node and the link or single link which will tell you the address of next node. So this is singly linked list. Next, the doubly linked list. So name tells double links. So now doubly linked list is double linked. So last type was single linked list where we are moving forward, but here double linked list. So double links are available. So one link is for the next node. So one link points to the next node, and second one more link points to the previous node. So this is like this. The structure is simple. So as you can see, there are, instead in a node there are two parts, but here there are three parts. Okay, as you can see the node, normal node. So this part will give you the link for next node. This is your actual data, and this part contains the address of previous node. So like this, a double linked list, using this double linked list you can move forward as well as you can move backward. So here both directions traversing is possible. So this structure allows us to move forward as well as to move backward. So now we will see a simple example how we can achieve the double linked list. So here I am drawing. So 1, 2, this will point here, since this is the first node, in previous node we will store the value null. Okay, this will tell that this is the head node. Okay, so head node, this is our head node where our linked list will start. This is 2000 location where our next element is there. So here the previous element's address is 1000, so it will point to the backward node. Next element address, if I am storing it as 3000, it will come here as 3000. It will store backwards address, that is, this is the end node, or we can also call it as last node. So you can see that, okay, in doubly linked list, first node's previous link will be null, as well as the last node's next link will be null. So this will indicate that from where the linked list, doubly linked list will start and where the doubly linked list will end. So this is the basic example of how a doubly linked list looks like. Okay, so next we will be moving forward for circular linked list, as the name tells. Okay, circular linked list. So it is forming a circle. When we are telling it is forming a circle, means from where we start, okay, we come back here itself. So first node is connected to the last node, or we can also tell that last node is connected to first node. So it is nothing but a newer version of singly linked list. So singly linked list means only a single link is present, but instead of the last node which contains null, it will contain the address of first node. So if we want to do like this, so I can write like this. So if I consider this as a last node, okay, 2, 3, 4, this is 10, 100, 200, 300. So 100 will contains the address of next node 200. It will contain the address of next node 300. It will contain null. So instead of null, I will store the address of first node is what, 100. So what will happen? It will point to this node. Okay. So this is the basic of circle is formed here. So the first node will be after the last node, or after last node we are pointing it to the first node. So this is how a circular linked list will be shown. Okay. So last one, as the name tells, okay, doubly circular linked list. So doubly circular linked list is nothing but where we are using doubly linked list. Okay. So we are using doubly linked list plus the feature of circular linked list, that is there are again per node contains 3 links, one to the previous, one to the current next node pointing. So here I will show you how actually it is looking. Okay. So this is how a doubly linked list looks like. Per node contains 3 parts. One is the link of previous node, the link of next node, link of previous node, link of next node, link of previous node, link of next node. So here in doubly linked list we are implementing circular. Circular means it should form a complete circle. So here if you are not considering this now, okay, so this will contain the address of next node is 200. So 200 will be storing here. So when it comes here, it will have the address of previous node 100. Next, the address of next node is 300. So it will come here 300. So address of previous node is 200. It will come here. It can come here. Then address of next node, as I told you, circular means it will come to the first node. The address of first node is 100. So you are noting here 100. So it will point here. Then when it comes here, you can see that the backside of this node, as we know, this node is backside of this. Since this is the first node, this is the last node. So this comes, the previous node is the backside node. So we are making here the address as 300. So it will point to the previous node. So this is how a doubly linked list can be implemented, where we are using doubly linked list and circular linked list to implement this particular feature. So these are the 4 different types of linked list, where how we can implement the linked list and solve our problem depending upon the given situation. Okay. So in next we will be studying singly linked list, the operations on singly linked list, how we are going to perform different operations. Now as we will be next moving on to the operations of singly linked list. So there are 4 different operations: creating of nodes, which are connected in the nodes are connected in the linked list, then how to do the insertion of nodes, deletion of nodes, searching, displaying and traversing. Traversing and displaying are little bit similar or same. In display we are displaying all the elements, but in traversing we are just traveling through all the elements in the linked list. So if we take a sample linked list like this, okay, the first node we call it as a head, and the last node usually contains the null. So the insertion, first of all we have to create a node. So for creating a node, we have seen the code, how we have to create a node. So once again we will see the code. This is how we can create a node. Struct node star, we call it as a create. So every time a new node we want to attach, we are using this particular function struct node, because we want a complete node. So we are using dynamic memory allocation size of struct node. So we already know the structure of struct. This is the structure of a simple node when we want to create. So struct node, int data, struct node. So I have told you why we declare like this, because we require the second part to be an address which can store the address of next node. So we are declaring it like this. Okay, next. So after declaring, we are now creating a node. So to create a node, we are doing like this struct node. So automatically it will call that particular structure. Then temp of data equals to data. Okay, in the data part we are storing whatever data we are getting. Then temp of next equals to node. So whenever a new node is created, like this, a space is created in the memory. Okay, this is data part. Okay, so data part will have whatever data we pass from here, it is getting stored in the data part of temp. So this one we are calling it as a temp. Okay, so data part we are storing whatever you want 10. Okay, next in the link part, as this is link, so in the link part what we are storing, a null. Okay, we are storing a null. So this is how we are creating a new node. Then we are attaching this to the linked list, whatever list we have created, there we are attaching. So how we are going to do the insertion, we will see that. Okay, so here there are different operations. Okay, so different operations are insertion we can do in 3 different ways: at the beginning, at the end, okay, or at the given position. Same thing, deletion at the beginning, at the end, ends from the specified node. And searching, that is traversing through the list, that is if we want to search an element through this linked list, what we have to do. So if I want to search D, I have to come from A to B, B to C, and C to D, because I don't have anything to directly access this D here. From A I cannot directly access D, so I have to, from A I have to travel to B. I have to see whether this B is equal to our searching element or not. Then I have to, again if it is not, I have to come again here, then again searching again here. So here we are using linear search, so we are traversing, we are traveling, so linearly we are traveling. So now we will see one by one how we are going to do insertion. So this is insertion at the beginning, so we are to insert here. Okay, this is our normal linked list. Here once I have created a new linked list temp. Okay, then I have to assign this null part is there. In here in the null part I have to store the address of head, because head contains, head is the first node, so I have to make this node as first node. So what are my steps? Create a new node. So I have to create a new node, points its next pointer, this one, this is a new link, or next pointer we can call to head. So we are making it to point to head, so we are storing this as here. Update head to the new node. So next what we are doing, we are storing address of this here, then this one I am renaming, this new I am renaming this as head. So how I am doing, new first, so this I am calling it as new first. Struct node malloc size of struct node, so dynamic cable. From here I am inserting the data, so I am inserting data in the new first data. So new first data I am inserting 45, then new first next, so this here it is null, so what I am storing, the address of head. So head I am storing here, so head by chance if it is having any other number, it will store in null. Okay, so instead of null it is updated with the address of this. Then head equals to first new, so first new I am renaming it as head. So how actually it is started, or how actually it is being processed, we will see. Okay, this is a normal linked list. We are creating a normal linked list. Okay, so this is our node. As this is the starting, I call it as a head node. Okay, then I am making second node, third node, and here I am storing null to tell that it is the last node. So now I'm giving it as 100, 200, 300. So this stores the address of next node. 200 stores the address of next node, that is 300. So now I am going to take a node called as, I have used new underscore first. Okay, whatever data I want to store here I am storing. Okay, next, new first. In the link part, what I am storing, in the link part I am storing here data. In the data part I am storing data, but in the link part, that is next, or I used here link, okay, there you are storing the address of head. So head is what here? What is the address of head? Address of head is 100. So I will store here 100. So when I store here 100, it automatically points here. So now it is pointing here. Now what I have to do? Now I have address of this. So what I have to do? I have to rename it. So what I am doing, instead of this head, now this is the first node. So what I am doing? I am redeclaring it as, or I am assigning head first as head. So what I am doing? New of first, I am storing it in head. So now new of first will not be there. It is called as the head node. So this is how we are inserting at the beginning. Okay, so next one is inserting at the end. So this is our linked list, and I have to insert a newly created node called as temp at the end. So to come at the end, I cannot directly jump here, correct? Because it is a linked list. I get this data when I travel from here. I cannot get directly here, 300 location where my data is there. So what I have to do? I have to travel from here to here, here to here. When we reach, when the link part is null, because we have to attach the new node to the end. So end node, how we can find out when it reaches null? Okay, so what I had to do? I had to travel from here to here. When I come here from head, what I had to do? For this purpose, I am using one more called as, okay, ptr, one more variable which will point to head. So what I am doing? Head I am not altering, because head I require, because it indicates the starting, so I cannot change this. So I am storing, or I am pointing one more pointer variable, pointer, which stores the address of first node. It will pointing to the head. Then what I am doing? I am traveling this pointer to the next node. If this is not null, then it will jump to the next address. So it will come here. So now pointer comes here. Okay, now it will check whether this is null, the link part is null. No, again you are jumping here. Now when I come here, then I am checking that whether this ptr is null. Yes, see, you can see here it is null. So whenever it reaches null, what we are doing? In this null position, just I have to write down the address of this temp. So instead of null, what I have to write here? I have to write here, what is the address? 400. I have to write 400. So what will happen? It will create a link here. Okay, just I have to do this. Then what I have to do? As usual, it is null here, so no need of doing this. Okay, so this is how we are going to do. So now through this we can achieve our operation of inserting a node at the end of the linked list. So now we will see how we are implementing through the codes. Okay, the same procedure how we are implementing. So first of all, okay, here we are at the end. So we are taking a pointer variable, as I told you here, a pointer variable which points here. Next, PTR of data equals to data. Okay, so this PTR is nothing but this temp. I'm using it as a PTR. Instead of temp, in this code I'm taking it as PTR. Then struct node travel. Okay, so struct node travel. So instead of here PTR, I have used a travel pointer. So travel equals to head. So as I told you, it will point, this node will point to head. Okay, so next this travel I am incrementing by the head. So I am linking it to head. So what I am doing, while, so traversing, while travel of next not equals to null, because we have to travel till the end. So I am checking whether travel of link, okay, whatever link I am telling, next or link, it should not be equals to null, then only I can travel. So what I am doing, travel equals to travel of next. So I am assigning, when it is not null, I am, instead of here travel, I am making the travel to point to this node. Then again I am checking whether, again it is going in the loop, checking whether travel of next is not equals to null. Again you are doing this. So when you reach here, okay, so this is your travel. Now you are checking whether travel of next or link is equals to null. Yes, it is equals to null. So what you are doing, travel of next. So your travel is here. Travel of next equals to PTR. So PTR value you are storing it in travel of next. So what is happening, you are creating a link here. Okay, so this is the code to do inserting a new node at the end of the linked list. Okay, so next one is, I want to insert a new node at a given position. So for example, a new node is here, the existing linked list is like this, and I want to insert at the given position 2. So here at the given position 2 there is an element that is 2. So instead of 2 I have to insert 5 here. Then the old linked list is like this, new linked list will be 1, 5, 2, 3, 4. So now I have to make a logic through which I am going to use this. So first of all, before this I have to check whether there are nodes in the linked list, then only, yes, if it is there, then I am inserting first whether whatever position I have specified here, if it is first position, then I have to insert here. So I have to do what, I have to call the function insert at the beginning, whatever we have studied previously, this code I have to call. So what I have to do, first of all I have to check whether whatever position I have described, whether it is present or not. Okay, so it should be more than 1. So what I am doing here, okay, insert struct node head. So as usual, you know, I am starting from here. So head I require insert position, that is in which position you want to insert. Next one is what data you are inserting, okay, that you are going to tell. Next one is I am going to check whether the given valid position or not, because if I give 0, it should not tell that you are going to insert in 0th location, because linked list usually start from 1. So I am checking here, if it is less than 1, not a valid position, then I am coming back, I am returning head. If it is not the case, I am checking whether ನಾನು ಇನ್ಸರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದಿದ್ದು ಹೊಸದು node, whichever I am inserting a new node, whether it is to be inserted at location number 1. So location number 1 means what, I am inserting at the beginning. So I am inserting at the beginning through this data, then I am returning this. So this is when, if it is I am inserting at the first position. Now think that I am not inserting in the first position, I am inserting in between. So I am inserting at position number 0. So what I have to do first I am assigning one more, as I told in the previous sessions that head I cannot move, because this head through this I am going to get from where actually I reading of the linked list. My linked list starts from head, so I cannot move this. So for this purpose, what I am doing, I am reassigning, or I am making one more counter, a variable which will store the address of first node. So it will be pointing here. Then what I am doing, I am taking up to here wherever I want to insert. For example, I have to insert in this position. So whenever I reach the position backside, so instead of 2, okay, now think that I want to insert in third position. So what I have to do, I have to take counter here, then in the link part I have to assign this. Okay, so for this purpose what I am doing, here I forgot to write this, 200, 300, 400. This is at the location thing 500. Okay, now I will start. So this 2 I am cancelling, 3 is there. So now I will start. So what I am doing, I am going to travel. Okay, here what I had to do, third position means what, instead of 3 I should get 5. So what I had to do, instead of 300 I have to put here 500. But if I remove first 500, what will happen, this 300, what will happen, this get detached. So I will not get where this third data is there. So what I had to do first, this 300 I have to store in null. So how I will get this 300, when I travel here, counter comes here. Okay, this counter comes here. So counter's next part is what, this. Okay, this I am storing in new nodes next part, null. So my basically what I am doing, when I am traveling, I am getting one step backward of this positions, one step backward. Then what I am doing, counters next, whatever is the link will be there or whatever is there, this I am storing it in new nodes. So this I am storing it in new nodes link part. So now here instead of null we are storing here 300. So same thing here. Okay, we have to travel till from first node, I have to travel till backside until and unless I reach null. So what I am doing, I am using a for loop, I equals to 1, I less than or equals to position minus 1. Okay, I am getting backside, just backside, counter not equals to 1, it is not null. Okay, so it is just you are making counter to come one step backside of this. Okay, position minus 1, the position is 3. So now position is what, 2. Okay, you are coming just one position backward. Next what I am doing, counter equals to counter of next. So position minus minus, position is 3, till now it is 3. Okay, so what I am making, I am counter, I am making here. So counter, now I am dereferencing here, I am making a new value 300. Okay, using this code. Next, when I do all this, where I have to stop, less than minus 1, position is 3, 3 minus 1, 2 I have to start, but position I value is what now, 1. So I have to travel. So now I am coming here, I came here. Now what is the value, I is 2, 2, position, pos minus 1, 3 minus 2, what is 3 minus 2, 1, I becomes 3 minus 1 is 2. So now you have to stop here. Okay, you have to stop here because after this I have to insert this node. So I have to stop one step backward, that is at the second node I have to stop. So this code will help me to stop at the backside position. Next, when I stop at the backside position, I have to check whether is the last node. If it is the last node, then I have to return back the head. Okay, I have to return back the head. So for that purpose, I am checking here whether if counter, if the enter position is not present. For example, whatever position number 4 or position number 10. 10 is not there, right? Because we have up to only 4 nodes. So we are using this code for that. Okay, this is before this code. Okay, because this code is when we move forward. So move forward is not possible. So before that we have to check. Now, after stopping one step behind, create a new node. So now we have already, I have created here a new node at 500 location. Next, what I am doing? New nodes next equals to, I am creating a new node to create a new data. New node is created. Next, new of next equals to counter of next. So as I told you here, counter of next value, what is there here? Counter is here. Counter's next value is 300. So before deleting this, I am storing it in one more. Otherwise, what will happen? I will lose this content. I will lose this link. When the link is broken, automatically what will happen? This will lose from where I will get. So I should not lose that. So what I am doing? New nodes link part, I am storing the counters next. So what I am doing? This. I am creating a link. Next, what I am doing? Now my counters next is here. So wow, now what I am doing? In this address, now I can remove this address, right? I can remove this and I can store this address here. So how I will store? Counters next. This is counter. Counters next. I am storing new nodes next. So I am storing new node address. So new nodes next I am storing. So new node next is this new node's address. Not next, sorry. New node's address you are storing 500. So here I am storing 500. So what is happening? Now I am creating a link here. So what happened? 1, 2, 5, 3, 4. So now I have inserted a new node at the position 3. Now this becomes third node. This is fourth. And this is fifth. So this is the code through which I can find or I can do inserting at a given position. This is to check whether we have entered a valid position, that is it should be greater than 1. Then if we are entering at the first position, then we have to do this. Next, we have to travel because I have to go one step behind. So we now has to traverse and stop one position behind. So one position behind we are using this code. Then counter equals to counter of next. Then if we are reaching at the end and still we are not got that position, then if counter equals to null, we are returning, that is telling that the enter position is not present. Then after that what we are creating, when I stop one step behind, I will create a new node. I will put that data in that. Then new nodes next I am adding or I am storing counters next, addressing new node next. Then counters next I am addressing new node. So first I am storing this address. Here whichever address is there I am storing here, new nodes link part. Then this complete nodes address I am storing here. So I am creating a link now. I have broken this link. I have created a new link. So this is how we are going to do the operation of inserting a new node at the beginning. Next, we have to see deletion from the beginning. So now deletion process has 3 points. So deletion at the beginning. So first we have to check whether list is empty. Empty list we cannot delete. So next what we have to do, update the head pointer. Okay, delete old head pointer. So what I have to do, if this is our linked list, this is our head. So what I have to do, first of all, I cannot remove this. If I remove this, what will happen? I will get lost. This link, I will get lost because this is, I'm getting this link through this address. Okay. So what I had to do, okay, if I want to delete, this is our linked list. Okay. So this is our linked list. What I had to do, I have to delete first node. So what I had to do, I cannot delete this. If I delete this, what will happen? The remaining linked list address I will not get, because from this I am getting the next node's address. So what I have to do before removing this, what I have to do, first I have to go to this node, then this one I have to remove, and this one I have to rename it as head. So what I have to do, this one I have to go for this head's link part is there. Okay, so what I will do, I will call this as temp. Then what I am doing, first node I have to remove. Okay, so first I have to check whether it is not empty or not. Okay, so through this code I can check whether it is empty or not. Head equals to null. So null means what? No elements. So linked list is empty. Now if it is not there, so to delete first node, store first node in temporary node, then free it. So temp, again I have storing the address. So like this you are making it to point to the head node. Next what I am doing, I am traveling to the next node. Heads next equals to head. Okay, so what I am doing, I am taking head to this. So how I can take head equals to head of link. So what will happen, I created this. So now head is here. So when his head is here, I can delete this because I got the head, right? So what I am doing, when I am coming here, I am making this, then free the first node. So I am doing free temp return head. So now what I did, I created this link list, then I am renaming it as temp because I have to delete this, so I am renaming it as temp. Next, I am reassigning head to its link. So what I am doing, head's link, I am reassigning it as head. So this will come here, head will come here. What will happen, this, I can now free this. So I am freeing this. So now this becomes the head. So deleting from the beginning is, deleting from the beginning code is like this. Okay. Okay, so next is deleting from the end. Simple thing, this is our linked list. The last one I have to make it null, and instead of that, which is backside, so I have to travel from here to here. I have to travel the node which is at the end node, it is having the link as null. So behind that, whichever node is there, since we are not using doubly linked list, we are using singly linked list, so we will not get the address of node which is previous to the current node. So we are making, or we are taking a pointer which is going backside of this, just backside of this node. So when I reach second last node, okay, what I have to do, instead of here the address, I am storing it as null. So what I am doing here, check if the list is empty, because for deletion we have to do that. If the list has only one node, remove that one node. If it is not there, then we have to travel the list to the second last node, we have to travel up to here. Then update the next pointer, this next pointer. Okay, null I had to do, delete the next pointer. So what I had to do, okay, if I consider this as one more node, okay, so what I had to do, I have to travel here. So for the traveling, I am taking a variable called as temp, and this is my method of doing. If you want to take only single variable, single pointer, no problem. Here I have taken 2 pointers. So what will happen, this will go one backside, backside, backside. So temp is the variable, okay, or temp is the pointer variable which will point to the node which we want to delete. Temp2 is the pointer which is just backside of temp. So we are now traveling, okay. So what is happening, one temp2 is here, temp will be here. So temp's link part is null, okay. That time what I have to do, temp2's link part, instead of 300 I have to put there null. So then this temp I can remove. So here I am doing that. First of all, I am checking whether the linked list is empty. If head is equals to null, linked list empty, I cannot do. If only one node is there, as I told you, if one node is there, okay, so I have to remove this. So what I have to do, this heads link I have to make it as null, then I have to free. So if heads link is null, free head equals to null, so finish. Okay, if it is not there, since our linked list is like this, what I have to do, as you can see, 1, 2, 3. So 2 additional pointer variables are pointing to the head. Okay, so I am taking here struct node temp head, struct node temp2 head, then start traversing with temp which is following temp2. So temp is following temp2. Okay, so temp I am removing. So what I am doing, while temp of link not equals to null, so temp is moving forward, so temp is forward, temp2 is backward. Okay, temp2 equals to temp. So what I am checking here, temp of link not equals to null, since we have to go to the last node. So temp of link not equals to null. What is temp of link? 200. It is not equals to null. So what I have to do, temp we have to store the address in temp2. What is temp now? So it has come here. So okay, next what I have to do, this is temp2. Then what I have to do, as you know, temp of link. What is temp of link? 200. So temp value is what? Temp is 100. So this is now what I am doing. This is temp. Okay, this I am removing. Temp2 is here. So temp's value I am putting in temp2. So temp value is 100. 100 I am putting in temp2. Then temp's link I am putting in temps. What is temp? Temp's link is 200. I am putting it in temp. Okay, same thing now. Again it will go back. Temp's link null. What is temp's link? 300. It is not null. So if it is not null, again what I have to do, temp value I have to put it in temp2. So temp value is what? 200. So 200 I am putting in temp2. So now the temp2 I am cancelling. Here I am putting temp2. Next, temp also is there and temp2 also is there. Same, both are pointing here. Okay, next what I have to do, temp of link I am reassigning it as temp. So temp I am cancelling it. Since it is not null, 300 is there, so it will go here. Now temp is here. Okay, so next come here. Now check, temp of link equals to null. So what is temp of link? Now it is equals to null. So what I had to do? Okay, temp2 of link. Since I told when it is backside, temp2 is here, temp is here. So when I reach end node, the second last node, this link I have to make it as null. So what I am doing? Temp2 of link null. So temp2 of link I am updating it to null. So what is happening? This link is disconnected. Next what I am doing? Okay, see, make link point to null. Next I am doing free temp. So what I am doing? I am making it as free. Next, temp equals to null. Since I am making it as free, then I am putting it null value such that the memory is also deleted. Then I am returning the head. This is the head. So this is how we are doing, okay, deletion from the end. Now we are going to study the last one, deletion from a given position. So here consider this as a linked list. Now I have to delete a position from 2. So this is 1, 2, 3. So I have to delete from position number 2. So I am taking pointers, 3 pointers, as usual head, which is pointing to the first. I am taking 2 more pointers, previous and current. So what is happening? Current pointer is the pointer which we want to delete, and backside. So backside, why? Because for example, if I want to remove this, so this address, this node's address I am getting from this. This node address from where I am getting from this. So if I remove this, what will happen? This will go off. I will not get this. So before removing this link, I have to make this address, instead of 200, I have to make it to store it as 300. Okay, so I have to make a backside of this. So what I am doing? Taking 3. So previous will always, this node will always follow the current node. So current node points to the node which we want to delete. Okay, so move current pointer. So we are moving current pointer till it reaches the given position. Then assign previous link to the current link. Current link is this. This I am assigning here. Okay, so we will see. Okay, first of all, as you know, we are making 2 point here, 2 nodes, current and previous. Next we are checking whether list is empty. If we are deleting from the position 1, okay, if the position is first position, we have to remove this. So this we have to make it as head. So what I am doing? Head equals to current of link. So current is this. So I am making this as head. This is current. I am removing this. So current equals to null. Okay. If it is not the case, now as we have stopped here, we will start from position not -1. That is, we are choosing, okay, the position to be deleted is 3. So this is our linked list, okay, where we want to delete this particular node. So I have to delete this particular node. So for this particular node, first of all, I have to travel from here to here to here, till I reach the third node. So when I reach the third node, I have to come here, 1 more pointer. So I have taken 2 pointers, current and previous. So current will move forward, previous will be just behind. So current will be here, previous will be here. At that time, what I am doing? Okay, so currents this address, because if I remove this, if I free this address will lost. Okay, so I don't want that. I want to connect this. So what I have to do? I have to logically connect this. So instead of 200, I have to put 300 there. Okay, so 300 I cannot get easily. So I have to go to this node's link part I have to access, and I have to store that link part, that is 300, in this memory locations link part. So for this purpose, we will now start doing this. So now what I am doing? Previous equals to 1, position is not equals to 1, position is 3. So it is not equals to 1. So what I am doing? Current value I am putting in previous. So current is what? 500. Previous is also 500. Both are pointing. Next, current of link, I am sending it in current. What is current of link? This. Okay, this is current of link. This current of link, I am storing it in current. So current was 500. Now what is current of link? 100. So now current will be pointing here. Okay, this link I have removed, overwritten. Now next one is what? Position equals to position -1. Position was 3. Now it comes to 1. Minus 1. Okay, not 1, sorry, 2. So now position is 2. Now it will come here. Whether position is equals to 1, No, it is 2, right? Position is 2 now. As I told, minus minus, so position is what? 2. 2 is not equals to 1. So again what we are doing, current equals to previous. What is current? 100. Previous was 500. So what I am doing? I am removing this. Again I am putting here previous. Okay. Next step is what? Current of link. I am storing, renaming, or I am assigning again current to current of link. So current of link is 200. So I am making this as current. This I am removing. I am coming here. Next what I am doing? Position minus minus. So what is position value? 2. Now position will become 1. Okay. Now again come here. Whether position is not equals to 1. What is position? It is equals to 1. Correct position is equals to 1. So what I have to do? I am going to exit from this loop, come out of this loop. I will come here. Now what I have to do? Now I am in this position, right? This link I have to remove. This node I have to do it. What I have to do? Currents of link. So what I am doing? Current of link, I am storing it in previous link. So current of link is 300. Where I am storing? Previous of link. Previous link is here. Current of link I have stored. So now I have created a link. Next what I am doing? Free current. I am freeing this. Now no problem. This link is disturbed. Next current equals to null. Since once I delete this, I have to make the position as null, that such that it can be used by other variables also. So now this is how my linked list will look. 1, 2 and 4. So now I have deleted this. So using this code, okay, I can delete from any given position. So this is the code where I am going to. So as I told you, here I have taken 2 separate pointers pointing to the head. But there are different methods. This is a one method. There is also a different method where without using 3 different or 2 different pointers, I can use only one pointer and use this particular or implement this particular program. So this is how we are going to delete. Okay. So next is, after deleting, our next one is these 2 points over. Now main thing is traversing and linear search. Okay, so we will be going through traversing and display is same. So traversing is we are going through each and every node. So for this purpose we are using this display. Okay, for traversing we are using this to print as well as to display. So traversing only we are using ptr equals to ptr next. So no need of this. This is only to print each and every node's data. So first of all, if the linked list is empty, I cannot display anything. So struct of node equals to pointer. So from head, okay, so from head I have to go through all this nodes. So I am taking head, okay, head. I am traveling till it reaches null. So ptr equals to null, so no elements. If it is not null, printing list element, while ptr is not equals to null, printf %d ptr of data, because here the linked list has 2 parts. One is data and one is link. So I want to print only data part. Linked list I don't want. The address I don't want to print. So only data part. Next where I have to go, ptr equals to ptr of next. So ptr is here. So I am redeclaring it as ptr. So every time ptr is incremented to next node. From next node only data part is printed. So each and every time you will go up to here till it reaches null. So this is the code for displaying as well as for traveling. For traversal we don't require to print the data. The same code will follow for traversing. So this is how we are going to do the traversing. Same thing whenever we are going to do the searching part, here we have to implement a for loop to print whichever element we are printing. We have to print that until and unless we reach null. If we reach null, we are making a flag which tells that the element is not found. Okay, otherwise what we have to do, we have to traverse to each and every node. When the searched value and the data in the pointer node matches, it prints that the searching element is found. So instead of this code, okay, instead of only this code, this code, we have to write linear search code, and this is to go to the next pointer. This pointer is there, so we are putting it in a for loop. Okay, so this is about the singly linked list, where we have seen all the operations. Okay, search, insertion, deletion, okay, traversing, display, creation and searching. So these all are the operations of singly linked list. Thank you everyone.